got this. Okay. Well, thank you for the opportunity to talk about this project. I'm going to talk about removing grass carp from Lake Erie, and want to start out giving credit to when I say we remove grass carp from Lake Erie, I mean a lot of people in my lab and in partner organizations that are out there on the rivers and the lake doing this work. Okay, so I'm assuming that most people in this crowd are pretty familiar with grass carp, but just to get everybody on the same page, why do we have a problem to start out with? Well, because grass carp were imported to the United States in the early 1960s for a reason, and it's because they eat a lot of plants. In this case, this carp is eating cilantro, which I think is an interesting picture. I don't know if it tastes soap or not, but I know that's a polarizing question. Um, I, it's a nice picture though, because we can't take pictures of anything in Lake Erie water. You don't get a picture. So they eat a lot of plants. So that is why they were imported in the first place, to clean out ponds and water. And that's great in your pond, but we don't want that happening in the lake. So herbivory, and there's no native fishes that are truly herbivorous. So this is a new component in our systems. And excessive herbivory can damage wetlands. So wetlands, we know, are very important to native species and to water quality. And this is just an example. The state of Ohio is investing a substantial amount of resources in the H2 Ohio program designed to rebuild and reconnect wetlands. So we don't want to undo that good work. Just a little bit of history. Grass carp were imported on purpose, and they're stocked in many places. In the mid 1980s, a process was developed to create infertile triploid fish in order to limit the risk of spread of fish into the wild. This is the most recent map showing where the yellow states allow triploid fish. There's a smaller number of states that, including Michigan, that completely prohibit grass carp, and there's also a smaller number of states that allow both diploid and triploid grass carp to be sold. And even though that process was developed to prevent the spread into the wild and the possibility of reproduction in the wild, it is happening. So grass carp reproduction has been documented in Lake Erie. That's the only one of the Great Lakes where it has been documented. Juveniles that were likely produced in the Sandusky River were found in 2012, and then the nail in the coffin happened in 2015 when fertilized eggs were found in the Sandusky River. So we know that spawning is occurring in Lake Erie, and that is what sort of prompted the need for a control program. The best time, and you've all taken ecology classes, the best time to control the best time to control an invasive species is before it's introduced. So once you've missed that opportunity, the best time to impact an invasive species is when abundance is relatively low. Typically, like all populations, invasive species can go through an exponential growth phase. And once that happens, the horse is out of the barn. So acting in these lower population densities are the best chance for success. So the control and research collaboration for grass carp in the Great Lakes or in Lake Erie. The direction comes from the Lake Erie Committee. We've formed an advisory committee with many, many partners that get together twice a year. And my first slide did not have co-authors on it because there's too many is the problem. We had to make a graph of all the collaborators on this project. So we have removal that's housed predominantly at the University of Toledo on behalf of Ohio DNR. We have removal at multiple places in the Fish and Wildlife Service. Lake Erie is centered in Detroit. and then Michigan DNR and other University of Buffalo and others on the eastern side of the lake. So one thing that's been really cool about working in this project is the flow of information and the collaboration between researchers and the removal work. So, this is our formal chart about how information flows, but people are literally on the phone with each other in the field. The early life history crews, determining whether eggs are present, communicating with the removal crews. We have a really high amount of collaboration and communication. And I think that's very important. And our goal, what we're trying to do, again, set by the management strategy out of the Lake Erie Committee, is to prevent grass carp from attaining densities that are going to cause harm. And we're trying to do that with science-based management, hence the need for the researchers and the removal crews to really work together. So how are we going to prevent this, density increase from happening? Well, we're going to control grass carp by removing fish or by blocking access. And most of the effort has been on removal. So another way to state this goal is that we are trying to become an unsustainable fishery. So all the good work that everyone in this room does on other Great Lakes fisheries, we're trying to flip it and do whatever you do, we want to do the opposite. We're trying to become an unsustainable fishery. The one thing that we do have in common with other fisheries is that we rely mostly on fishery-dependent data. So that kind of affects how we do analysis and how we interpret things. So how does the control program work? We do have some fishery-independent data. There is, we call it standardized sampling. It's basically stratified random sampling design. We started out using electrofishing and have added gill nets to that mix, and I'll talk about that change. The problem is that it doesn't produce many captures. So it becomes very difficult to use this highly zero inflated data. So what we do have is our catch data, which is fishery dependent data. Two ways that we go about capturing fish. They aggregate for spawning, which I'll talk about in a minute, during high flow events, and that frequently we can get a pretty high catch out of those events, but they're based on the weather. So they're completely unpredictable, can't plan for it. So it makes, just relying on those events very difficult. We also do regular targeted sampling where we're going to places where we know the fish are aggregated, but they're not in the dense spawning aggregations. And this has more variable catch rates. So what has the catch been? Here's a graph showing captures of grass carp back to about 2012. And at this point in the early teens, these were mostly incidental catches or occasional agency captures that were not targeted to grass carp. There was some effort in 2017, but really systematic effort at removal began in about 2018. So these are fisheries catch data in some ways. So we can think of them with a basic fisheries equation. The population has some biomass, and that's not a number that we know. And catch is related to that biomass by fishing effort and a quantity called catchability. So effort obviously went up when control started. So we see this big jump in the number of fish captured, and that was not, I don't think anyone thinks that's because the population really expanded at that time. When you start fishing, you will catch more fish. So we see an increase in the catch or the number of fish removed when effort began, but effort can't be infinite. You can't just increase removal by infinitely increasing effort. So that leaves us with manipulating catchability. So catchability can be thought of as efficiency, or fishing power is another way that people describe that. So I think that sort of captures a lot of the work that's gone on recently has been trying to increase that catchability or being more efficient in removing grass carp. So some of the things we need to know to increase catchability are when to look, where to look, and how to target the fish. What kinds of gear, what kinds of technology can we deploy to help fish more efficiently? It would also be nice eventually to know how it's working. So let's start out with when we should be looking for grass carp to remove them from the system. So this is work from a graduate student at the University of Missouri who works with USGS at the Columbia Research Lab. And what she did was examine the gonads of grass carp these are all from Lake Erie, and she classified them into different stages of development. And the blue and the purple stages, the later stage development, 3s and 4s, are ready to reproduce. So what she saw in looking at Lake Erie is these blue and purple development stages are present from April until November. So there's some reproductive ready fish at any time during the sort of, field season in Lake Erie. More additional work from Justin Bopp, who's now with Michigan DNR, and quite a number of colleagues, many of whom are in this room, were able to show with fish with telemetry tags that we refer to as trader fish because they've been tagged and released to snitch on their friends, so we can figure out where they are and how they're behaving. And he was able to show that most of the grass carp that are in the Sandusky River are in the river and moving up to the spawning grounds by about May 30th. So even though the previous work showed that fish may be ready to spawn in April, May is probably when they are getting into rivers and actively moving. During a field season part of the year, we also know something about the conditions when fish spawn. So this is showing the hydrograph of the Sandusky River with discharge on this axis throughout the months of the year. The blue dots are times when grass carp fertilized eggs were detected. And the yellow dots are when we did not detect fish. So the probability of detecting eggs is the highest when the temperature is above 18 degrees, which, depending on the year, usually happens in May, and when flow is at a certain level. So there are occasions when flow is high and we don't detect eggs, but when we do detect eggs, flow is high. And the probabilities are based on work by Sabrina Jaffe and Song Chen at the University of Toledo and others. So we know something about when to look for grass carp. Where should we look for them? So in general, grass carp and the other 3 species of invasive carp that are in North America are adapted to rivers. They all come from China. Think Yangtze River, they're big river fish. So they are adapted to spawning during high flow events in rivers, and they gather in those rivers for that purpose. So even when there's not a spawning event, fish do tend to aggregate in tributaries. So searching rivers is much easier than searching Lake Erie. So most of the control work happens in tributaries. So which tributaries are we focusing on? Spawning has been detected in 3 tributaries on the western end of Lake Erie. The first was the Sandusky. We've also detected spawning multiple times in the Maumee. The Huron River, we've had detection of 2 spawning events in that place. We look in other tributaries. So these other tributaries that are labeled in both Ohio and Michigan have been sampled repeatedly, and we have not seen evidence of spawning in any of those at this point. So we know broadly which rivers are the most risk. We know a lot about the Sandusky. That was the first place that spawning was detected, and it's where a lot of the effort has gone into. So through multiple lines of evidence, we know about at least 1 spawning ground in the Sandusky River. And it's in Fremont, Ohio, right above Brady's Island. So there may be one additional place where spawning occurs, but this is a place that we can target for removal when there's a spawning event. We know quite a bit about how fish move around in the river based on telemetry, and I might need help. If you can click on, yeah, just click on that. So this is showing us what was a spawning event in 2023. And you're seeing fish sort of gathering in the lower river. So here's the bay. There's fish gathering in the lower river, running up to Brady's Island, and then coming back and spending time in the lower river. So this tells us, this confirms where the fish are going during the spawning event, but it also tells us something about where they're spending time downstream in the river, and that has become more and more important to know about that. And we wouldn't have a lot of this information without the telemetry projects. Oop, didn't want to do that. Could you advance? Thank you. So telemetry has given us a lot of information about where fish are at different times and what time of day those movements are happening. And that's something that we have been able to exploit with the gears that we have been using. These maps are sort of a time series of where catches have happened across the years that intensive sampling has been happening. So every gray dot is a sampling event that did not result in a grass carp. So you actually can't see the river under the gray dots. So effort is fairly high. And the blue dots in different colors, depending on what section of the river they were collected in, are showing where captures happen. In 2020 and in 2021, a lot of our captures came out of the sort of mid-river main stem of the river. And that seemed to kind of wear off in 22 and 23. We were putting in a lot of effort and getting fewer captures in the places where we had been. In 2023, these light blue dots up here are showing a new area of the river that we were able to access with using a smaller and much more nimble vessel. So getting into that previously unexploited area resulted in a lot of captures. But it required a change in fishing approach that we'll talk about in a minute. And then the past 2 years, we've been getting a lot of captures in the lower section of the river. Again, that required an adaptation in gear and shifting how we were fishing in those places. So we'll talk about those in just a second. The Maumee River, which is another place where spawning has been consistently found, it's a much larger river, and frankly, we know a little bit less. There has been modeling work out of USGS to estimate where spawning locations happen, where spawning is happening. The models predict up to 12 different spawning locations. So 12 is a lot. That's not good news. The even worse news is that many of these locations are in difficult to access areas. So they tend to be in between riffles without boat ramps. So getting into those areas is also driving new methods, approaches for getting into those places. Another scale that we're working on, and this is work out of from Rob Hunter, who's both a USGS employee and finishing up a PhD at the University of Toledo, is mapping likely locations to look for grass carp at a larger spatial scale. So at the Great Lakes Basin-wide scale and at a regional scale. And that's based on habitat associations that he's documented from the Sandusky River. So we know a lot about when grass carp are in locations where we can capture them and where they are. So how do we capture them? Again, I'll come back to information derived from telemetry studies that showed that, especially in the Sandusky River, there are hot spots of movement by grass carp. Most of them are associated in the Sandusky River with backwaters. So this work, again, out of the Columbia USGS lab and many people in this room, showed that fish are sort of disappearing off the telemetry grid during the day. They're almost certainly entering the backwaters, and then they come out at night. So this was something that helped. Oop. Did I hit the wrong button? Okay. Sorry. Hit the wrong button. This was work that helped, along with some serendipity of terms of getting new gears just at the right moment. Um, these are the same maps that we looked at before, but they're coded now by type of gear instead of just by location. So I mentioned that in the past 2 years, we've had a lot of success capturing fish in the lower Sandusky River, and that has been through implementing gill nets in those locations. So most of these gill nets are set overnight based on the telemetry information that's when fish are actively moving. They're hiding in backwaters during the day and coming out, and we're coming out and moving during the night, and so they're vulnerable to these passive gears. That's been a really great trend to have these increased catches through gill nets, and we hope to improve on that. In 2025, multiple partners, including USGS, Fish and Wildlife Service, and Toledo and other partners, ran a preliminary study to look at timing of gill net catches and the effect of mesh size. So what we saw was that maybe a little bit ironically, but smaller gill nets captured more grass carp than the largest set that we used, and we captured many more fish overnight than during the day. So this is going to be pursued again this year with input from a master's student at University of Toledo, and she is going to try to implement even smaller meshes to try to capture hopefully more and smaller fish. So one of the benefits that we hope to realize by using smaller mesh gill nets is catching smaller fish that will allow us to capture some of the more recent cohorts of grass carp that have been produced. So from our catch data, this is the number of fish of the diploids in blue and the triploids in yellow that are showing in the diploids cohorts of fish that were produced first in 2011, and now we're seeing another cohort showing up that was produced in 2019. So typically with both electrofishing and the gill nets, we're not capturing a lot of fish that are younger than 4 or 5 years old. So the hope that implementing smaller gill nets will allow us to catch fish sooner after they've been produced, and hopefully before they become reproductive, which in Lake Erie, multiple lines of evidence suggest is about age 3. So we would like to catch them as soon, as close to reproductive time as we can. Again, this is work from Rob Hunter, who's finishing up his PhD in a week and a half, if anybody would like to come visit. And he showed earlier on in the program that we can be more efficient, just like we're trying to get more efficient with the gill nets. The original electrofishing in the program often included a trammel net that crews electrofished around. And Rob was able to show that while that had a slightly higher catch per unit effort in terms of just fishing time, that when you added in the bycatch and other processing time to set the net, it really increased the amount of the hours that crews were taking to handle that gear. So we have switched from, when electrofishing, from using a trammel net to being able to cover more ground and becoming more efficient in that way. So I mentioned before that we had quite a few catches in this difficult to access spawning area. It's above the spawning grounds. It's in a city park in Fremont. There's no boat ramp in that area. And you have to get over the riffles right below that area, which is, one of the features that attracts the carp to spawn in that area. But it becomes very difficult to get a boat into. We were able to borrow a small metal vessel in 2013 that we were able to get into that area. That required crews usually to get out of the boat and push it up over the riffles, and I mean the boat got dented. Is basically what happened. So what we're pursuing now is building smaller vessels. This is a raft that the University of Toledo was able to get on the water last year, and Fish and Wildlife Service Detroit has a raft that was built last year that should be on the water this year. So this raft last year had the highest CPUE for electrofishing of anywhere, and that's because we are able to get it into areas that have received less exploitation, and I think that are attractive to the grass carp. They tend to be areas that are bounded by riffles, sometimes upstream and downstream. So there's short stretches of river, and there's no boat access except through the riffles. So I'm hoping this year something we want to work on is accessing areas in between riffles and the Maumee River. Some of those have been identified as possible spawning areas. And we also want to prioritize areas where we know that the diploid percentage of the population is higher. So both UT and Fish and Wildlife will be deploying these rafts this year. So we've talked about when, where, and how we are looking for grass carp. And I'd like to end by talking about assessment of how it is going. Before I do that, I'm going to come back to our project structure graph. And I think that the successes we've had has really depended on this communication between researchers and the implementation crews on the ground. This has been a project where, grad students are very regularly coming to the twice annual meetings and presenting their work as soon as they know it. They're not sitting on things and waiting for publication. They are sharing the information with the people that, can actually do something about it right away. So I think that has really helped in these efforts. So a graduate student, former graduate student at the University of Toledo, developed an approach to estimate mortality of the population based on an adaptation of a standard catch curve kind of approach. And so Caitlin Lang was able to develop a relationship between this annual mortality rate that she estimated and the number of fish that were removed in that year. So there is a relationship between the number of fish that are removed and the mortality of the population. I mean, it's also generally a time trend. The more recent years tend to be the higher mortality. Those are also the years when we have captured the most fish. So, and there's some additional work being done on this at the University of Toledo. Justin Meyer is a PhD student working with Song Chen, is looking at some different approaches to possibly to estimate mortality that will refine this. But I think the trend is there in this this way of looking at it. This is work by Josh Hochwater, who's a postdoc researcher housed at the University of Toledo and working closely with us and with USGS. And he's in the process of developing a modeling approach to come up with a relative abundance index. So we're not saying that we have a population estimate of grass carp. I mean, just the way I've explained how we're really removing them from tributaries and from rivers. We're not, fully accessing the entire population. But of the fish that enter the rivers, the index that Josh has developed, the relative index that Josh has developed, is showing that the relative catch per unit effort for both the Maumee and the Sandusky River has shown a decline through time. So we've had and this is based on electrofishing data. So since 2022, we've had consistently low catches in both the Maumee and the Sandusky River with electrofishing information. I showed you that the past 2 years we've been capturing most of the fish we catch with gill nets. So this time series we either have to figure out how to patch together electrofishing and gill nets, or we have to have two separate time series of index. So back to the beginning. I think that we're showing some evidence that by starting early, we have not hit. Grass carp have not really shown any evidence that they're hitting an exponential population growth phase. That we have, at some level, accomplished control. We are not seeing the increase that would be expected with unchecked control. And there's some evidence that we are impacting the population in the places where we're working. So take homes, finding invasive species can and should get harder if control is effective, because you're fishing a smaller and smaller population. We have to evolve how we fish. We need to follow the fish at the right time, right place, and with the right gear. And partnerships and rapid flow of information has been critical to success. Thank you to all the partners and to this group.